Question number 5. Two particles P and Q are projected vertically upwards from horizontal ground at the same instant. The speed of the projection of P and Q are 12 and 7 respectively. So let's say this is P. So its upward speed or speed of projection is going to be 12. And for Q, the speed of projection is 7 meters per second. And the heights of P and Q above the ground t seconds after projection are hp and hq respectively. Each particle comes to rest on returning to ground. Find the set of values of t for which the particles are traveling in the opposite direction. Okay, so initially both the particles are going upwards. Since P has a greater initial speed, it's going to reach a greater height. And Q has a smaller initial speed, so it's going to reach a smaller height. So this V is going to be 0 for P, and this V is going to be 0 for Q. Okay. So now let's say P will reach this height, this will be height of P, and Q will reach this height. Now after reaching this height, Q will start falling downwards. But at this height, P will continue going upwards till it reaches its maximum height when the velocity or speed becomes 0. Okay. So we have to find the time when of this part. So what we're going to do is we're going to find the time for which particle Q reaches its maximum height and the time for which the particle P reaches its maximum height, and then we'll subtract these two times. That will get us the answer for part 1. That would be when the particles would be traveling in opposite direction, because this one would be still be going upwards and this one would start going downwards. Okay, so let's talk about particle P first. So U is 12. Since it's going upwards, A is going to be minus 10 and V is going to be 0. And we need the time. So we can use V is equals to U plus 80. 0 is equals to 12 minus 10 times T. T comes out to be 1.2 seconds. And for Q, similarly, U is 7, A is minus 10, V is 0, and we need T. So V is equals to U plus A T. T is coming out to be 0.7 seconds. So the question had asked, find the set of values of T for which the particles are traveling in the opposite direction. So the answer should be T is between 0.7 seconds to 1.2 seconds. This would be the answer for part 1. Part 2 says, at a certain instant, P and Q are above the ground, and this equation holds true. 3 times HP is equals to 8 times HQ. HP and HQ is the distance traveled by P and distance traveled by Q. Find the velocities of P and Q at this instant. Okay. So now we have to use this equation. 3 is equals to HP is equals to 8HQ. Okay, so what do we know? We know U again. For P, we know A, and we need the equation for S, and we can use T in it. So we can use UT plus half AT square. So 3 times UT plus half AT squared minus 10T squared is equals to 8 times U for Q is 7. So 7T plus half AT squared. We simplify this, get a value of T. And once we have t, we find the respective v's. Okay, let's see what do we get here. 3 times 12t minus 5t squared, bracket close, equals to 8 times 7t minus 5t squared. Okay. So we get 36t minus 15t squared is equals to 4, 56t minus 40t squared. Rearrange this. All right, so this simplifies to 25t squared minus 20t is equals to 0. And then you can take 5 common on both sides, or divide 5 on both sides. 5t square minus 4t is equals to 0. Take t common, 5t minus 4 is equals to 0. We get t is equals to 0, and t is equals to 4 over 5, which is 0.8. So at 0.8 seconds, this equation holds true. 3 times hp is equals to 8 times hq. And now we have to find the velocity of p and q at this instant. So for p, we know that u is 12, a is minus 10, and t is 0.8. We have to find v, so we can use v is equals to u plus at. So 12 minus no, this is minus 10, I'm sorry. So 12 minus 10 times 0.8, which gives 4 meters per second. And similarly, we can get V for the other particle Q. For Q, we know that U is 7, A is minus 10, and time is 0.8. So again, V is equals to U plus A T, which gives minus 1 meters per second. So the difference in sign shows that both the particles are moving in opposite direction.